All right, students, thanks for watching. This video is going to go through the transformation of functions. So I'm in Desmos because that's my favorite way to graph. I'm going to start with the basic parent function x squared. We should know that is a parabola. Okay, we will use a table of values, but we're going to assume we already know that's the shape of the parabola. What we're trying to do is understand that the family of functions is this. Anything that's x squared is a parabola. So if I put a new equation, that would look exactly the same. Let me make it a little different. Let me go subtract 5 from it. And now we get a parabola again, but it's in a different location. So again, parent function is x squared, so this function has the same features, but the minus 5 shifted everything down by 5. Okay? You can see that visually on the graph because 0, 0 went down to 0, negative 5. This point 1, 1 here also got shifted down by 5. This point got shifted down by 5. Every single point on here got shifted down by 5. Okay. And let me get these ugly markings off here. And let's show you a different way to see that. Another way to see it is by going plus and adding table. And then I like to have my table at the bottom. So let's put it, you can drag and change the order. So table here goes 0, 1, 2, 3, 4, 5. And you'll notice it didn't fill it in. We have two functions to choose from. So I'm going to label the first one f of x. And you'll notice it doesn't fill it in until I put x1. And now it fills in our table based on this equation. The g function is the same exact function, but shifted by minus 5. How does that look in the table? I'll put g of x1, and it's the same numbers, but everything is shifted by 5 units. Okay, it's like we took all the numbers from here and shifted them by 5 units. All those shifted by 5 units. Okay, what if though, what if I put that minus 5 inside? Take a look at that. Now it's harder to see on the table, okay? So let's take a look at over here. It went from 0, 0 to 5, 0. Now that makes sense, it shifted by 5. What doesn't make sense for a lot of people, and this is understandable, why is it 5 here when our equation had minus 5? Well, you got to think of this. This was 0, 0. Putting the minus 5 here changed the characteristics. Now it's shifted by 5 units. But it's shifted by 5 units in the next direction, and it's like this. The question I ask myself is, where's the new 0? The new 0, 0 is at 5, 0. Let me say that one more time. It used to go through 0, 0, but now because of the minus 5, it's not minus 5. Positive 5 is what gives you your new 0. So that is backwards. I know that. That's a little bit confusing. Okay. But check this. If we put plus 5, suddenly now it's over at negative 5 because, again, negative 5 is the new 0. Okay. It's a little harder to see with the table values there, but that's always the rule. So if it's inside, it's horizontal. If it's outside, it's vertical. Now our final thing here, final thing we could do, we could put a number in front. We could put a number like 2. We could put a number like 3. Put a number like 4 or 5 or 6. And what you should see is the graph is getting skinnier. Okay? Or you could say it's getting narrower. Our textbook will call that a vertical stretch. It calls it a vertical stretch. It's being stretched in the y direction. Okay, so they call it a vertical stretch. You can call it narrower, whatever makes sense. The main thing is you want to know that the bigger number is making it change in that way. So if that's a bigger number, let's go with a smaller number like 1/2. And you see it gets wider. You go 1/4, it gets wider. 1/9, and it gets wider. So the number in front can make it wide or skinny. Okay. So wider or skinnier depending on what number you're putting in here. And it doesn't have to be a fraction. It could be a decimal. You could put 0.01, 0.04, 0.7, whatever you'd like. Okay, you can change it and play around with it. And I encourage you to try those numbers until you figure out what it does. And if you're really curious, then you try a negative number and you're, whoa. Now taking a look, negative is actually not too hard to see on the table because it just took all our numbers and turned them negative. All right. Let me take out the 0.7 here, and then you'll see it for sure. All the numbers, same numbers in our table, except for the g function has all negatives, whereas the f function has all positives. All right, so let's summarize this. I'm going to get rid of these. I'm going to show you one last feature. If you put a letter A here, you can add a slider. And you can see that A makes it wide or skinny. Skinny or wide. Again, you can even make it flat if you want to. All right, there's your graph. If you put a number inside, let's put H for that. And that's nice because it reminds us of horizontal. The H slider will slide it left or right. And now you can see you're going doing horizontal shift. Finally, you can add a letter at the end, and that will give you a vertical change, a vertical shift. So notice, the graph stays exactly the same. You're just changing the location of this key point here. And by the way, that key point there is called the vertex. We're changing the location of the vertex. Now take a look. You might notice something here. Whoops, they erased them again. Sorry, that won't work. But your numbers on your vertex should be the same as the numbers you have up here. That's not a coincidence. Let me say that one more time. It's not a coincidence that the numbers you see here are the same numbers you see here. Okay, these numbers are the vertex, and they're controlled by the equation. So let's back this up a step, and we'll actually use real numbers instead of all this H and K and all that stuff. This, again, though, is vertex form, and you do want to know it. But the reality is, most of the time, they're going to have numbers for this. So let me cut that out. We'll start with x squared, and our next function will be g of x, and this is where we'll put this back in. Let's give a value like, well, let's not give a value yet. We'll change that. Put a 3 here and a 4 here, and take a look. Bam. Where's the vertex? 3, 4. We can copy that. We can paste it. I don't like to use the same letter, so we can call this h of x. And this one I can put minus 4. And take a look. This one's 0, 0, 0, then 3, 4. Anyways, it shifted down to 3, negative 4. This is not clicking right. There we go. There we go. So you have control now over where it is in the XY plane. You can move it anywhere you want. Let me call this one K of X. And let me change this one to minus. Let's put this one on a plus 4, minus 4. So again, we have control over everywhere that vertex goes. So again, this is called vertex form. It's important to know it. And we'll use it a lot. And if you learn it well, here's the deal. That's always going to be left or right. That will always be vertical. So learn it well for this chapter. And these rules apply whether you're doing x squared, or x cubed, or x to the 5th, or what other power. Even a square root function, same rules apply. Left or right shift, up or down shift. All right, try those out. Send me questions. Thanks for watching.